In this series of videos, we've been looking at how to make the JTAG interface as robust as possible. So far, we've shared best practices on how to get the grounding and terminations right. And in this video, we're going to show you how to create test reset sequences. A test reset sequence is a set of commands that initializes the JTAG devices to get them ready for subsequent instructions. The first stage is to ensure the JTAG signals have been correctly defined in the pin mapping screen. Here, I've already allocated the 4 mandatory signals: TDI, TMS, T-clock and TDO, but it's worth commenting on the test reset pin, which I haven't yet added. Because it's an optional signal in the JTAG spec, it's not listed here as a standard pin type, so we're going to have to create our own. I want to put it on this pin, so I right-click on it, and we need to make it a programmable input-output, so select PIO from the options that pop up. That's now created an output we can use for the test reset, and I'm going to change its name to a standard NTRS-T. Now that all the signals we need have been defined, you can start putting them into the sequence, and you'll need to go to the Test Reset Sequence tab for that. Create a new sequence by clicking Add and giving it a name. You now need to add the signals into that table. Click on Add Pin down here and select the required signals one by one. We recommend using Test Reset, T-clock and also TMS. The reason we suggest including TMS is to guarantee it remains high throughout the reset process. That will ensure any devices in the chain that don't have a test reset pin can't accidentally execute instructions if they power up in an unusual state. Now you've told it what pins to use, you can start to create the signal transitions. Let's do TMS first, which I said we wanted to keep high. You do this by highlighting the cell and then pressing the space bar or by double-clicking. Now add additional steps into the sequence by clicking Add a few times. Then we come to Test Reset, and there are a couple of things here you need to be aware of. We've found that some devices don't initialize correctly if the low to high transition on the reset occurs too soon after power-up. Also, although the spec defines reset as an asynchronous signal, some manufacturers have implemented it synchronously. To work around that, we're therefore going to add a clock pulse at the beginning, so use the space bar or double-click in step 2 of the T-clock row to create one. Then you can set the transition on the test reset line. Add a few more steps to extend it to the end of the sequence. And then add another clock pulse after the reset's been taken high. But don't stop there. Virtually without exception, all reset sequences must include what's called a TMS reset. That's a sequence that puts all the JTAG device's tap controllers into a known state and causes them to put their ID register, if they have one, between TDI and TDO, ready to receive their first command. And by the way, if they don't have an ID register, then they'll use their bypass register instead. Inserting a TMS reset is simply done by clicking Add Step and selecting TMS Reset. That's now a good test reset sequence for most systems. By the way, it's worth noting that the steps on this graph don't represent time, but simply a set of transitions. So if you need to add a delay into your reset sequence for some reason, don't try to do that just by inserting a transitionless step. Instead, you must define a sleep period, which is done by using Insert Step and selecting Sleep. You can then define the delay you want in milliseconds. Remember that different boards may have their own individual requirements, of course. For your setup, you might have additional signals you want to control. Perhaps you've got a watchdog you need to disable, for instance, in which case you'll have to add another line for that. You do it by assigning the relevant connector pin as a PIO, just like we did for the reset line, and then renaming it as you wish. It's also important to check the devices you're using in case they have any special requirements you need to allow for. Some DSPs, for example, require several clock pulses before the test reset line is taken high, so check the datasheets for any special demands imposed by the parts you're using. Once you've done all that and have a good test reset sequence in place, you can start to run the JTAG chain. And in the next couple of videos, we're going to share advice on how to ensure it runs well at high speed. So please take a look at those. Checking its high speed performance now could avoid many problems later. If you found this video helpful, please subscribe for more and leave a like or comment below.